In this video, we are going to discuss the problem broken blocks. In the game of broken blocks, the player will allowed to move on a m into n blocks, okay, in which there are m levels and n stone blocks. So these m into n blocks are arranged such that there are m levels and n stone blocks on each level. Fine. So these levels are vertically above the previous one, just like a staircase, with some of its stone blocks replaced by wooden blocks. Okay, this is what given to us. So we will understand it in the whiteboard also more clearly. Fine. So what a player can do? A player can start the game present at the ground level. The player can start from any of the blocks present on level 0 and start moving further to next levels. The player can only move to the stone block just above the present block or diagonally left or right. So the player can only move just above or diagonally left or right to the present stone block. Also, a player cannot move on the same level and the player cannot step on the wooden block. Fine. This is what given to us. At the last, we have to find out how it is given that in each of the stone blocks, we have some gold coins present. So we have to find that the player aim to collect as many gold coins. We have to find the maximum number of gold coins the player can achieve. Okay, this is what we have to find. So now let's understand this first of all more clearly. So this is the test case given to us. Okay, this is the same test case which was given to us in the example. You can see here, this is the test case given to us, and the answer of this particular test case is 14. If I take 6, then 3, then 5. You can see that 6 plus 3 plus 5 is 14. This is how the player will move and collect 14 stones. But how he will collect 14 stones? We will understand that. Okay. So first of all, we have to find that this is the case given to us. This is the case given to us, and let's first also try to observe that how these levels are arranged. These levels are arranged. For example, if I explain it in this particular grid, you can see that you are at particular this position, or we will start from start. For example, this is the ground. This is the ground floor. This is ground floor. This is level number 0. This is level number 1. This is level number 2. Okay. Now you can step in any of the 3 blocks here. For example, you step in this particular block here. Now you can move either this side or just below, because you cannot move here. There is no block available. So for example, you have moved to the left side here. Okay. Then there are 3 possible. This one, this one, this one. This is how you can tell. Okay. So for example, if I am currently at the ground level, then there are many possible ways to reach a particular cell. For example, if I tell you that you have to reach this particular block, this particular stone block. Also, we have to observe one thing, that we cannot reach a wooden block, because one cannot reach wooden block. If the player will reach a wooden block, he will fall and die. So we don't have to use any wooden block. We can just reach up to the stone blocks. Okay. So for example, this is the block where we have to reach. This is the block. So how many possible ways are there to reach this block? Let's first count the possible ways. So what, for example, here is the player. Player can start from here, go to this one, then here, then here. This is the first way how a player can reach to this particular block. Now, for example, player is here. He can go this side, then to 3, then to 4. This is also a possible way. Now, one more possible way. Player is at here. He can go to 6, then 3, then 4. So these are the 3 possible ways how a player can reach this particular cell 4. Okay. So what does it mean? It means that in this particular problem, to reach a particular cell, there are multiple paths available. Means greedy technique, we cannot use greedy technique here. We cannot use. We have to check for all the paths. And for that, we will use dynamic programming here. We will use dynamic programming. Okay. This is what we have to observe. The first thing we have observed that we have to apply dynamic programming algorithm here, because this cannot be done by greedy algorithm, greedy technique. Okay. Now thing is, how can we apply that? How can we apply dynamic programming here? Okay. Yeah. So first of all, we will observe that how will it, and one more thing, we have to solve this particular problem with O1 of space complexity. Means we will not use any other space. We will not use any other space. Okay, we cannot take any other array, or we cannot take any other vector. We have to solve the problem with O1 auxiliary space complexity. Okay, so now so obviously if we cannot take any other space, so obviously we have to update this particular matrix only. We can only update this particular matrix. So I have created this particular matrix as the updated form of this matrix. How I will update this? Okay, now the thing is, what does this matrix contain? So this matrix will tell that if a player is reaching for at a particular cell, for example, the player is reaching at this particular cell, then how much maximum coins the player can get if he has to reach this particular cell. This is what we will try to implement. We will store such values in this matrix such that if a player is reaching, for example, this particular cell block, then how many maximum number of coins he can get. Because there are multiple paths. You can see there was multiple paths. The path was this also was a path, this was a path. There were multiple paths to reach a particular cell. But here we will store that which path is giving us the maximum number of coins, and I will store that value of coins here. That after reaching this particular point, the maximum number of coins one can get is this. Whatever, we will find that. Okay, so this is how we will create this. So now, what will be the base condition? Now we will discuss about the base condition. How can we do this? How can we perform this? So we will start from each and every cell. We will iterate through the matrix. So we will do this in O1 only. So maybe I am taking a separate matrix here to explain you, but when I will code, I will tell you that how can we perform this particular algorithm in only that same matrix. We will update only that matrix. Fine? The thing is that if I have to reach this particular block, for example this one, we will first of all talk about this particular block. So how many coins the player can get? How many maximum coins one can get? So obviously the player is currently at this is the ground level, this is the 0 level, 1 and 2. These are the levels. So obviously if the player has to reach this particular cell, so he can just get 2 coins. He can just start from ground and then reach this particular cell. So maximum number of coins player can get is 2. So I will write 2 here. Okay. Now what I will do? Now to reach this particular point, let's take these both the points. Similarly, to reach these both the blocks also, the player will get 5 and 6 blocks. Fine. This is how we will update this particular matrix. It will store how many maximum coins the player will get after reaching a particular block. Now, the next thing, if the player has to reach this particular block, then what will happen? You can see that this particular block has -1, means it has a wooden block. So the player cannot reach this particular block. So obviously we will store -1 here. -1 means that player cannot reach this block. It is a wooden block, or maybe he cannot reach this block. We will understand that condition. That is a corner case. We will understand that. Okay. Now if the player has to reach this particular block, then how many gold coins he can get? How many maximum gold coins he can get? You can see that to reach this particular block, there are 3 possible ways. First way, second way, and third way. Player can be here and can reach here, from here to here, and then from this block to this particular. These are the 3 possible ways how the player can reach at that particular block. Okay. So, but we have to take that path which is giving us the maximum number of coins. So you can see here that if the player will start from this third column, then he will get the maximum number of coins, which is 6 coins. And here we have 3 coins present at that particular cell. So total we will have 9 coins when the player will reach this particular block. Maximum of 9. Okay. Now similarly, we will do this for all the cases. If I talk about this particular cell, you can see here is the 2 present, and the maximum of will get when the player will start from 6 to 2, means it will get 8 coins. The path is, this is the path I am considering. This is the path I am considering, means player started from the ground level, then goes to 6, then goes to 8. So after reaching this particular cell, how many maximum number of coins he get is 8 coins. 6 plus 2, 8. And yeah, 8 is here. As you can see, 8 is here. Similarly, for this particular block, this one. Now, for this block, if I talk for this particular block to reach this particular block, which is this one, how many possible ways are there? There is only one possible way. Means if we talk about the above level only, if I have to reach this particular block in from the above level, means this particular level, then how many possible ways are there? There are only one possible way, because the player cannot start from here. Here is a wooden block, so player can only start from this particular block and then reach here. This is the only way. And here the player is getting 9 points, and at this particular there are 4 points. So total there will be 13 points after reaching this particular block. So I will update the value and write 13. Okay. I hope this is understood. So now I will update here 13. Now for this particular block, you can see that there is a -1, means the player cannot reach this particular block. So here will be -1. For this, you can see here is a 5, and to reach this particular block, there are two possible ways. The first possible way is from this block to here, and then from this block. There is other two possible ways. So obviously, the player will take the way with maximum number of coins, which is this one, 9 coins, and 9 and 5 coins are present at that particular block. So there will be a total of 14 coins. Okay. So there will be at this particular level, if I talk, there will be total 14 coins. Okay. Yeah. And now if we talk that how many maximum coins the player can get, so we will find the maximum of this whole matrix. And the maximum of this whole matrix is basically 14. So 14 is the answer. Okay. 14 is the answer. Now maybe you have a doubt that why we are taking the maximum of this whole matrix. Okay. So I will explain this with another example. Okay. So let me erase this thing. Okay. Now let's take an example. I am saying this because, for example, there is a 2, there is a -1, there is a 3, there is a -1, there is a 2, there is a -1, there is a 2, for example, and then there is a -1. So if I update this particular matrix, you can see that for this it will be 2, -1, 3 only. Okay, that's the base condition. Because a player can start from here, then he can get 2 coins here, 3 coins here, and he cannot reach this particular point. Then for this particular cell, he can get 4 coins. 2 plus 2, 4. Means this is the path he can follow. So he can get total of 4 coins. For this particular cell, player can get 5 coins. But then the player cannot move downwards. The player can start from here. Okay, the player can start from ground level, then go to here till here, and he can get 4 coins. Then, or he can start from here, then go to this particular cell, then he can get 5 coins. But there is no more way to continue. Player cannot go downward in another level because there is -1 present. Fine. So that is why we will take that for each and every cell. That, for example, if player is just going to this particular cell, maybe player is just able to go this particular cell. After that, the path is blocked. In that case also, we have to take the maximum of this whole matrix. We have to take the maximum of this whole matrix. Okay. Yeah. So now one more thing is there. For example, we will understand this is a corner case. So after that is a final corner case. After that, we will go towards the code part and we will understand the code more clearly. How can we implement this particular logic, this particular dynamic programming algorithms? Okay, algorithm. So I will modify this particular test case in such a way that I will be able to explain you the another sample case. For example, this is the current given to us. Fine. So for example, there is 24 present. Okay. And in place of this 3, there is a -1 present. Okay. There is a -1. So when I will update the values, it will be 2, 5, 6, then -1. Then you can see that to reach this particular 2, there was 8 coins. 6 plus 2, 8. So I will store 8 here. Then for this, I will store 8 plus 5, 13. Okay. Then -1 here and then 24 here. So after finding the maximum of this whole matrix, I will get 24 as the answer. This one. But 24 is not the answer. Because even player it is not possible to reach this particular block. Because this block is blocked by the path. There is no path to reach this particular block. If one will try to start from here, here is also wooden block. He cannot reach. Here is also wooden block. So this path is blocked. One cannot reach this path. This path is unreachable. So in that cases, if a particular path is unreachable, we have to update the value of that particular path is equal to -1. So now 13 is the answer, which is the correct answer. The path we are taking for 13 is this one, 6 to 13. This is the path player will follow. Fine. So now let's move towards the code part. Okay. Implement these particular solution. So first of all, we will find the length of the matrix, 2D matrix. Okay. Dimensions of the 2D matrix. So these are the, I will store number of rows in n and number of columns and okay. Now what I will do, I have to iterate through the matrix. Fine. But as I told you that the first row of the matrix will not be changed. The first row will remain as it is. For example, you can see here the first row of the matrix was 2, 5, 6, and in this case also the first row is 2, 5, 6. So we have to start from the second row. Means if it is a zero bias, if we take it as zero biased array, means obviously it is a zero bias. This is the array number 0, means row number 0, row number 1, row number 2. So we don't have to update the 0th row. We have to start from the 1th row, first row and the second row. Okay. So we will start from the first row and then we have to check for each and every column. We have to update the values of each and every column. Okay. So now I will start from the first row. I will not take the 0th row, and then for each row I will take all the columns. Okay. Now what we have to update. The first thing is this. The first condition is that if the value at that particular cell is -1, then obviously one cannot reach that particular cell. We have to just continue. Else, for example, if we are at a particular index, for example, let's take our index to understand. For example, if we are at index, let's first update or change the values by a little bit. Okay, so that it will not be more confusing. Like this was the original array. Fine. So for example, we are at this particular index. So there are 3 ways to reach this particular, and we will take the maximum of the 3 ways. These are the 3 ways. The first way is this, the second way is this one, third way is this one. We will take the maximum of these 3 ways. Okay. So first of all, we will find the maximum of these 3 ways, and then I will add the value of the maximum, which is 6 to this 3, and that will become 9 at the last. Okay. So now let's code this. I will take a variable, for example, mx, which will be -1. Okay, it will be -1. Now I will take the maximum. Okay, so first, if the value of j to avoid the overbound, okay, to avoid the overbound, I will also take a condition, because if j is less than 2, then only we will take that mx is equal to max of mx comma matrix I -1 j -1, because if j is equal to 0, then in that case this element will not be present. So I will just take else if, no, I will just take if, because I have to find for all the 3. If j is less than m -1, in that case only I will take mx is equal to max of mx comma, I have to take comma here. So mx comma matrix I -1 j plus 1, and then obviously I have to take just above element. For that there should be no condition. That will be max of mx comma matrix I -1 j. Okay, these are the conditions which we have to. Now in this mx we have the maximum of the above 3 element present, and if the maximum is -1, means there is no path to reach that particular cell, as we have discussed. Now that in this case we have discussed that for example, if I have to reach this particular cell, there both the blocks were -1, means both the blocks were blocked. So I cannot reach this particular. So I have to also change the value of this particular block, which is equal to -1, and I have changed the value of this also, is equal to -1. So in case if all the above blocks are -1, means one cannot reach to that particular cell I comma j. So I will make the value of that I comma j is equal to -1 for future reference, because we have to iterate through the array. We have to iterate through the matrix in the earlier levels also for their reference. Okay, yeah. Now else, if it is not -1, then we will simply update the value. We make it like matrix ij plus is equal to mx. Okay, this is what we have to do. Okay, this is what we have done. Fine. Now the next thing, what we have to do, we have to find a maximum. We have to find the maximum of the whole matrix. That is what we have discussed. So we will store that maximum in the answer. And the answer will be 0, because in the worst case also there will be 0 coins at least. Means the player will not get any coin. It cannot be less than 0. It cannot be negative coins. So answer will be 0. Then I will just iterate through the whole. So I will take just answer is equal to max answer comma matrix ij. Okay. So here we are finding the maximum of this whole matrix. Fine. Yeah. So now, so this is what we have discussed. The same thing we have discussed in our whiteboard. Okay. And we have implemented that particular logic. So what we have discussed, we have to first iterate through the matrix and we have to update the same matrix. We cannot take any other matrix. Okay, that's the thing given to us. We cannot take any other matrix. Fine. And then what we will do, we will just count and update the matrix. Then we have to find the maximum of that whole matrix. Then we have to find the maximum of that whole matrix. That is what we have to do. Okay. Yeah. So now let's first submit the particular code. Okay. We will just submit the code. So this is the code which we have written. So first of all, we have to return the answer. Okay. Yeah. Now we will run the code first. So our sample test cases are passed. Now we will submit it. So all the test cases are passed. So if we talk about the space complexity and time complexity of this particular solution, so as I told you, the space complexity of this particular solution is O1. O1 is the space complexity, and if I talk about the time complexity, so it will be O of n into m, because we have used the nested loop, or we have to iterate through the matrix, so it will be O of n into m. So I hope you got the video. If you have liked the video, please hit the like button, please comment, please share this video and subscribe the channel.